Spatial variations in static skin deformation and perceived roughness of macroscopic surfaces. I briefly summarize the perception of macroscopic and microscopic roughness. These two types of roughness can be categorized by the surface wavelengths of grating roughness scales. The macroscopic roughness is characterized by the wavelengths greater than a few or several hundreds of micrometers. The microscopic roughness is solved by the smaller wavelengths. Corresponding mechanoreceptive units are different between these two types of roughness. Slow and fast adapters are in charge of the macro and micro roughness, respectively. Suitable hand motions are also different. Pushing the surface is satisfactory for macro roughness, whereas scanning or rubbing motion is required for the perception of micro roughness. Because of the difference of neural coding, related skin deformation is different. In the case of micro roughness, the vibration of finger pad is known as an important cue. For the macro roughness, the spatial deformation of finger pad may be a determinant of perception. In this study, we pursue this part. Let's consider the perception of macro roughness from the viewpoint of skin deformation. Skin indentation into the grooves is considered important. Actually, the groove width mostly determines the subjective roughness. The spatial deformation of skin leads to the spatial variation of SA1 activities. This variation well corresponds to the subjective roughness. We try to bridge the gap between these psychophysical and neurophysiological studies. I explain the procedures of our study. First, we take photos of skin deformation when the finger pad is laid on the grating scale. Then the surface displacement is extracted. Second, we compute the spatial spectra of skin deformation using a Gabor filter with varying wavelength values. Third, the subjective roughness is investigated by the method of magnitude estimation. We used 16 types of surfaces. Finally, we conducted the correlation analysis between the spatial spectral components and subjective roughness. They exhibited a high correlation coefficient of 0.94. We found that the subjective responses to macro roughness can be linked to the spatial variation of finger pads deformation. So the perception of two types of roughness can be summarized as follows. The macro roughness corresponds to the spatial variation of skin's deformation. The micro roughness corresponds to the temporal variation. Finally, we note the most sensitive spatial component that depended on individual participants, but on average, it was 2.66 mm, which is consistent with neurophysiological understandings. That's all for this video. Thank you very much.